So, hi everybody. Today's lab is about springs, and it's not really just about springs. If we want to be more general, it's about a property that a lot of different materials have called elasticity. So this is what elasticity is all about. Let's take this rubber band as an example. Okay, right now I'm just holding the rubber band. I'm not stretching it or compressing it in any way, so this is what the rubber band looks like. But of course, if I start pulling on it from one end, I'm going to stretch it out. I'm going to make it longer. But as soon as I take that force away, it goes back to its original position. So that's what elasticity is. It's going back to its original position after being deformed in some way. So we have an equation already that pretty well describes elasticity in materials. It's called Hooke's law. So if you remember, this is what Hooke's law says. It's a relationship between the force you apply to something and its deformation. Okay? So right now, I'm not applying any force, so there is no deformation. If I apply a little bit of force, the rubber band stretches a bit, so there's a small amount of deformation. If I apply a bigger force, there's a bigger deformation. It's being stretched even more. Hooke's law says that the force and the deformation are just linearly proportional. Okay, so one is just directly proportional to the other. You might remember the equation F is equal to kx. That's what describes this linear relationship between the force and the deformation. Okay? Now Hooke's law is just an equation. It may or may not describe the way things work in the real world. So our job is to put Hooke's law to the test by testing it out on two different objects. We're going to use a spring to start. So in other words, the experiment is going to go something like this. We'll hang some mass from the end of the spring. That's an applied force. And as a result, the spring is going to stretch out. Okay, the more mass we hang, the more the spring stretches out. We're going to look at what the actual relationship between that force and the deformation is. Okay? Then we're going to do the same thing with the rubber band. Okay, we're going to hang different amounts of mass from it. We're going to watch how, as we increase the mass, the rubber band stretches more and more. And we're going to look at what the relationship between the force and the deformation is. Okay? And then we'll see in each case, does Hooke's law actually apply? Does Hooke's law accurately describe what's going on here? That's the goal of today's lab. Okay, so this is our experimental setup for the first part of the experiment. It's very simple. What we have here is a stand horizontal bar that goes across like this, and at the end of that horizontal bar, I have a spring hanging from there. So our job is to see if the spring follows Hooke's law. So what we're going to be doing is hanging different amounts of weight from the end of here, and then seeing how much we stretch the spring out as a result of that. Okay, so in each trial of the experiment, we're going to be measuring two things. The amount of mass hanging off the end, and also we're going to measure the degree of stretching in the following way. I'm going to measure from the floor to the last turn of the spring's coil right here. So we're going to measure from the floor to the last turn of the spring's coil. And with no weight hanging from the end of the spring, that height off the floor is 142 centimeters on the dot. So 142 centimeters is that first height. Okay, so next, we're going to hang some weight off of the end of the spring. We're going to start with 100 grams. So here's how we're going to do this. I have a weight holder that has a mass of 50 grams, and then I have a slotted mass that also has a mass of 50 grams. So I'm just going to put them together like this for a total of 100 grams, and then hang this off the end of the spring. I'm just going to lower it very slowly so it's not bouncing up and down. And then I'm going to make the same measurement that we did before. What is the height from the from the floor to the last turn of the spring's coil right there. So let's measure that. Okay. And so what I'm getting is 129.5 centimeters. Okay, and we'll keep going with this. I'm going to take 100 grams, so I have a 100 gram slotted mass, and add that to what's already there for a total of 200 grams, and we'll see that the spring stretches out even further. So I'm going to try to hold it still so it's not bouncing up and down. And then once again, we're going to measure the height from the floor to the last turn of the spring's coil. And in this case, we are getting 116.5 centimeters. Okay, in this experiment, we just continue on by adding more and more mass to the end of the spring, stretching it out more and more, and then just keep measuring the amount of deformation each time. I'm not going to show you the rest of the trials, but we're going to be doing 300 grams, 400, 500, and then 600 grams hanging off the end of the spring. So the numbers or the measurements for those trials, I'm just going to flash up on the screen right here. Right, so the next part of our experiment is to investigate the relationship between the applied force and the deformation for a rubber band. Okay, so we're going to start this way. I have a 50-gram weight holder hanging off the end of the rubber band, and what we're going to do is measure from the floor to the bottom part of the rubber band right there. We're going to measure that height, and what I'm getting is 154.5 centimeters. Okay, so it turns out the rubber band is a lot more stiff than the spring. It takes a lot more force to get it to be deformed by a given amount. So we're going to make a really big jump and add 450 grams to our weight holder. So we have a total of 500 grams on here. And barely anything happened. You see that? It did stretch out a little bit. So what we will do is measure that height once again from the floor to the bottom part of the rubber band. And what we're getting is 151.5 centimeters this time. Okay, so we just did 500 grams hanging from the rubber band. Now we're going to do a whole kilogram. And this is a kilogram weight holder. I'm going to hang this from the end. The rubber band is stretched out a little bit more. And again, we're going to measure the height. Okay, so what I'm getting here is about 148.3 centimeters. The rest of the experiment goes in much the same way. We'll continue to add weight at the end of the hook, and as we add more and more weight, we'll stretch the rubber band out more and more. We're going to go in increments of 500 grams, so we'll keep adding 500 grams until we reach a total of 4 kilograms, at which point we'll end it, because right now, as you see here, the rubber band has 4 kilograms hanging off the end, and it's really stretched out. So we're at the point where it's probably going to break if we add very much more, so we'll just end the experiment here. Again, I'm not going to show you those trials on video. I'm going to flash those numbers up on the screen at the end of this video so you can take the data. And that's it for today. If you follow along with the handout that goes with this video, you should be able to complete the rest of the lab. So I'll see you in the next one. Until then, be safe and be healthy out there. Take care.